Here's lesson 29b, remainder and factor theorem. We're going to get started with dividing using synthetic division 2x cubed minus 9x squared plus 6x minus 2 by the factor of x minus 4. Now remember, with synthetic division, if your divisor is a factor of x minus 4, then for synthetic division you use the 0. So off to the side, I'm going to solve that just in case any of us don't know how to do this. Set the factor equal to 0 and solve for x. When you do, you get x is 4. Now we set up our synthetic division, where we have 4 on the outside, and then we have our original polynomial. We're just going to use the coefficients. I caution you to look for any placeholders you might need. In this case, we have x cubed, x squared, x to the first, x to the 0. We don't need any placeholders. So we write the coefficients corresponding to their variables. And now we apply our synthetic division. Remember, you add the insides and you multiply the outsides. As Ms. Weissmuller says, drop it like it's falling. That's step 1. So step 1, drop the first term like it's falling, and you get 2. Now what's 2 times 4? That's 8. Add together negative 9 plus 8, we're at negative 1. Multiply 4 times negative 1, we're at negative 4. Add together 6 and negative 4, we have 2. Multiply 4 times 2, we have 8. Add together negative 2 plus 8, and we're left with 6. Remember that 6 is your remainder. Okay, remember 6 is your remainder. If that remainder had been 0, then we would know that x minus 4 is a factor. So this lesson is talking about the remainder theorem and the factor theorem. So there's going to be a fun thing we're going to learn about this remainder, and that's on the next slide. Example 2, we're going to let p of x equal 2x cubed minus 9x squared plus 6x minus 2, and we're evaluating p of 4. Now this is the exact same polynomial p of x as the last problem, and we're evaluating at that same 0, 4. But I want to show you something. So when I evaluate, remember we're saying when x is 4, plug it in, right? P of 4 is when x is 4. So we have 2, and then we have 4 cubed minus 9, 4 squared plus 6 times 4 minus 2. Now when we evaluate that, we have to make sure we're doing our PEMDAS. So we're going to start with our 4 cubed, right? 4 cubed. And at this point, right, okay, so we have 2 times 4 cubed is 64 minus 9 times 16 plus 24 minus 2. Now when you evaluate this, you're going to get the answer of 6. That's interesting. So what this means is that whether I use synthetic division or whether I evaluate, I'm getting the same answer. Remember, this was the remainder of our synthetic division. That's important because that implies that anytime I ask you to evaluate something, you can actually use synthetic division, and the remainder is the evaluation of it. So that leads me into the 2 theorems we're learning today. The remainder theorem. When a polynomial p of x is divided by a factor of x minus a, doesn't have to be a factor, but right, we're claiming that's the factor. The remainder is equal to p of a. So this is saying that the remainder is what that evaluation equals. And we just saw that in example 1 and 2. As I mentioned in lesson 29a, the factor theorem, right, if I were to use synthetic division with a 0 and I got that the remainder was 0, then I know that x minus a is a true factor of the polynomial p of x, meaning it's a 0, it's a root, it's something I can graph on the x-axis because the y value is 0 when I have that x value. Okay, example 3. Example 3 leads us into divide p of x, which is x cubed plus 5x squared plus 5x minus 2 by x plus 2. Now, I don't know that that's a factor, right? It doesn't tell me that this is a factor. So I'm going to use my 2 theorems, and remember, if I get a remainder, then that's not a factor. If I get a 0 as a remainder, it is a factor. Because that's a linear x plus 2, we're going to use synthetic division. I use my 0, which is -2, and I set up my synthetic division. Again, I caution you to look and see, is there any missing term in your polynomial p of x? Again, we have x cubed, x squared, x to the first, and x to the 0. Therefore, no missing terms, no 0 placeholder needed. 1x cubed, 5x squared, 5x, -2 as the constant. Step 1, drop it like it's falling. 1 times -2 is -2. 5 plus -2 is 3. -2 times 3 is -6. 5 plus -6 is -1. -1 times -2 is +2. And when I add those together, I'm left with 0. This means that I have a factor, right? This must be a factor, also known as a 0, or a root, or a solution, right? This implies that that x value of that factor is all of these things. Last but not least, x-intercept. Okay, so that then tells me that x squared plus 3x minus 1 multiplies with x plus 2, and that equals x cubed plus 5x squared plus 5x minus 2. If the problem wanted you to go further, which in the future problems they will, so I'm going to elaborate on this a little bit, we need to remember that this is a quadratic. So if it were to say solve instead of divide, I would need to go further. So let's remind us, solve, right? What does solve mean? Solve means I want to find all the zeros, roots, solutions, or x-intercepts. I know one of them for this polynomial is -2, but where are the other 2 solutions? Well, that would mean I'd have to use either completing the square or quadratic formula to solve this. I'm going to use quadratic formula. So we have x is equal to -b plus or minus the square root b squared minus 4ac all divided by 2a. In this case, when we evaluate that, we get -3 plus or minus the square root of 13 divided by 2. Now I can't go any further, so I'm going to end this with, these are my solutions, right? I can't simplify the square root of 13, so my solutions for this polynomial are going to be -2 and -3 plus or minus the square root of 13 divided by 2. This would be my final answer if it asked me to solve. On to example 4. Example 4 says, determine whether x plus 2 or x minus 2 is a factor of x to the 30th power minus 4x to the 28th power plus 4x minus 8. Now hold on, wait a second. You're asking me to go to the 30th power and the 28th power with something? Yeah, but let's use our calculator, right? We can use our calculator to do this. So if I were you, I would pause this for a second and I would input the value of x store -2, and then we're going to evaluate it. You go to your home screen and you then type x to the 30th minus 4x to the 28th plus 4x minus 8. When you do this with your calculator is then taking -2 to the 30th power minus 4 -2 to the 28th power plus 4 -2 minus 8. When you do this, you get that the answer, right, the calculator is going to produce -16. Well, what does that mean? Well, that means that when I plugged in -2, I had a remainder, right? And when I have a remainder, does that mean it's a factor? In this case, no. So that means that x plus 2 is not a factor, right? Okay, now let's see that with the other one they wanted. Now that's going to be let x equal 2, right? If I let x equal 2, because the factor was x minus 2, let's see what happens here. So now again, go to your calculator and store the value x stored 2. Then type in x to the 30th minus 4x to the 28th plus 4x minus 8. When you do that, again, you're getting 2 to the 30th, 2 to the 28th, plus 2 minus 8. And when you do this, your calculator should produce the answer of 0. That implies that p of 2 has a remainder of 0, which means, right, that x minus 2 is a factor. It is a factor. Now, if you didn't want to use your calculator, we could also use synthetic division to do this. And I'll, if you want to see that, come to FIT and I'll show it to you. For example 5. Okay, example 5 says solve x cubed plus x plus 10, which equals 0, given that negative 2 is a root. So they're not giving us a factor. Instead, they're giving us that x value of negative 2. Okay? Like I said before, make sure to always check, do you need a placeholder? In this case, I do, right? I see that I'm missing that squared term. So when I do the synthetic division to solve it, right, because what does solve mean? Solve means find all possible roots, right? That means all possible roots is what I need to find. Now, if I'm finding all roots and I see that my polynomial has a degree of 3, then I'm actually looking for 3 different x values. Okay, so I'm going to set up my synthetic division. I know that this is negative 2, because that's what they told me. The root is negative 2. We have 1x cubed, 0x squared, 1x, and positive 10. Ms. Weissmuller says, drop it like it's falling. And here we go. 1 times negative 2, negative 2. Drop that sum, negative 2. Negative 2 times negative 2 is positive 4. 4 plus 1 is 5. 5 times negative 2, negative 10. And sure enough, 0. Now, I have to get 0, right? This is implied because they told me it's a root. Okay, so then what does this represent my answer, right? I have x squared minus 2x plus 5. I have to keep going, right? Because it said solve. So now I set this equal to 0, and I'm going to solve it. Okay, so I'm going to bring this up here, and we're going to solve this like we did with quadratics. I could 1, complete the square, 2, quadratic formula, or 3, factor. Now, what multiplies to 5 that adds to negative 2? That's right, nothing. That's right. So I'm going to complete the square on this problem. So we have x squared minus 2x plus 1 minus 1 plus 5 equals 0. From here, I'm going to then say that that's x minus 1 squared, which equals negative 4. From there, I square root both sides, and I get x minus 1 is equal to the plus or minus of 2i. From there, I say, well, that's x is equal to 1 plus or minus 2i. So my final answer, the roots of this polynomial x cubed plus x plus 10 are negative 2 and 1 plus or minus 2i. Okay, so then we're on to example 6. Find the value of k such that x minus 3 is a factor of this polynomial, 3x cubed minus 5x squared plus 4kx minus 6. Now, a lot of us, when we see a k problem, maybe we start sweating and anxiety happens, but I want you to calm down and remember that synthetic division is your friend, and 4k is just like a coefficient like 5, negative 6, 3. It's just like that. So I'm going to set up my synthetic division. Remember, if this is a factor, then I have to find the 0. So do you agree the 0 would be 3? From here, I'm going to set up my synthetic division. Again, look for any placeholders may need. I have 3x cubed. I have negative 5x squared. I have positive 4kx. And then I have negative 6 as my constant. So no placeholders needed in this problem. Step 1, drop it like it's falling. We have 3 that drops down, so now we have 3 times 3. That's 9. Negative 5 plus 9 gives me 4. 4 times 3 is 12. Add this straight down, and this is where students get a little tripped up. They're like, wait, how do I add 4k plus 12? When you do exactly what you just said, 4k plus 12. Last but not least, 3 times 4k plus 12 becomes 12k plus 36. When we add that column straight down, 36 will add with negative 6, so I'm left with 12k plus 30. And some of you are like, wait, we didn't solve for k. You're right, not yet. We're almost done. Not quite done, but we're almost done. From here, this is the remainder, right? Okay, that's the remainder, and that has to equal what value? Well, if they're telling you in the problem that it is a factor, well, what value of a remainder is a factor? Good, you're screaming 0. That's exactly right. So we have 12k plus 30 equals 0, and we're going to solve for k. We have 12k is equal to negative 30. Divide both sides by 12 and simplify your fraction. We're left with negative 5 halves, and that would be the value of k. Folks, that's it for the lesson. Good luck on the homework. Have a good day.